So in this video, we are going to be revising straight lines. Now this video is only for JEE 2025 aspirants. It is not for 2026 aspirants. It is for those people who have already completed the chapter straight lines and are currently in class 12. The reason why why I'm making this video is because revision is equally as important as completing your topics. Like whenever you complete a new topic and you keep on proceeding with the syllabus, you also must revise the topics that I already covered, because that is what is going to help you at the end. When you give your JEE mains January attempt, you need to be thorough in all the topics. You need to be revised in all the topics, such that you don't forget any of the concepts that you learned. So this will be approximately 1 hour video, and this will revise a complete chapter of straight lines for you. So let us start. So first thing is quadrants. Quadrants is a very basic thing. Like there's two axes. There is a x-axis and there is a y-axis, and that divides the entire space, the 2D space, in 4 quadrants. First quadrant, second quadrant, third quadrant, and fourth quadrant. Now first quadrant, every point is of the form positive comma positive. Second quadrant, every point is of the form negative comma positive. Third quadrant, every point of the form negative comma negative. And fourth quadrant is every point of the form positive comma negative. So this is a very simple thing that you have to know. Secondly, for any point alpha comma beta, if it is there in space, then the distance of alpha comma beta from your y-axis will be its x-coordinate. Now here actually it should be mod of x-coordinate, because distance can never be negative. So for example, if you have something like minus 2 comma 1 is a point given to you, and they're asking the distance of this point from y-axis, then its distance will be 2, right? Similarly, if they ask the distance from x-axis, it will be its y-coordinate. So distance of this point from your x-axis will be 1. So that's also one important thing that you have to remember. Another important thing is reflection. Some basic reflection. See, actually there is a formula for reflection which we'll be learning later, but these are just some basic reflections which you have to keep in mind, because sometimes in questions they'll use it, right? So reflection of point about various things. First about x-axis. So suppose say you have any point alpha comma beta, its reflection about x-axis will be alpha comma minus beta, right? And I think it's very obvious why, because if you consider this x-axis to be a mirror, then the reflection of this point will be at an equal distance. It's a property of plane mirror, right? Whatever is the distance of the object from the mirror, same will be the distance of the image also from the mirror. So therefore, if this is beta, then this must also be beta, but in the opposite direction. Therefore, it will become alpha comma minus beta. Similarly, reflection about y-axis will be minus alpha comma beta, and reflection about the origin will be, for this you have to consider a mirror along the line y is equal to minus x, something like this. This will be the mirror, right? And this will lie along the line y is equal to x, alpha comma beta minus alpha comma minus beta, and the mirror will be along the line y equal to minus x, and therefore the reflection of the point alpha comma beta about the origin will be minus alpha comma minus beta, right? This is another thing that you have to remember. Next thing is distance formula, which is very important. So like if you have any 2 points x1 comma y1 and x2 comma y2, the distance between the 2 points can be given by the formula under root of x2 minus x1 the whole square plus y2 minus y1 the whole square, which is a very basic formula. Next one is section formula. Now in section formula, the very first case that I'm taking is where a point P is dividing a line segment AB internally in the ratio m:1. And for this, I hope that all of you will know the formula. The coordinates of point P will be m times x2 plus m times x1 whole divided by m plus n, and the y coordinate will be m times y2 plus n times y1 whole divided by m plus n. If this is x1 y1 and this is x2 y2, and P divides it in the ratio m is to n, right? In that case, this will be the formula. The second case is when P divides the line segment AB externally in the ratio m:1. Now this is the case where most of the people get confused. Now you have to listen to this very carefully. In this case, this is a line segment AB, right? And this is the point P. And the point P, if they say if point P divides the line segment AB externally in the ratio m:1, you have to, this entire diagram has to come to your mind. This is what they mean by that. Basically, if you extend AB and you join to point P, your AP is to your BP is m:1. That is what they mean by point P is externally dividing the line segment AB in the ratio m:1. Okay. Now many people will only memorize the formula, but this diagram is also very important. You need to know what it means for a point to externally divide a line segment, right? This is very important. And in this case, your x coordinate of the point P will be m times x1. This is your m and this is your x1. This is your m, this is your x1. M times x1 minus n times x2 whole divided by m minus n, and your y coordinate will be m times y1 minus n times y2 whole divided by m minus n. This is also very important, right? Next one, this is very important topic of the chapter straight lines. Basically, you will be learning about certain shapes. You need to know the properties of certain shapes. Like first you have triangle, then we'll be learning about a parallelogram, then we'll be learning about rectangle and so on, right? So first we'll start with triangle. So you need to know the definitions of all this terminologies that I'm going to say. If you are already studied and you forgot, please revise, right? So first one is median. So median is basically a line joining the vertex with the midpoint of the opposite side in a triangle. So basically, if this is the vertex of a triangle, then this is the opposite side to the vertex, right? And this line which joins the vertex to the midpoint. Midpoint is basically like if this is opposite side, the midpoint divides it into two equal halves. The line joining this opposite vertex to this midpoint, this line is known as median of the triangle. Okay. Then what is the centroid of the triangle? Basically, centroid is a point of concurrency of medians in any triangle. Like a triangle may have three medians, because obviously there will be three vertex, and through each vertex one median will be passing. This is your first median, this is your second median, and this is your third median. And all these three medians will be passing through one point. They will be concurrent, and that point will be a centroid of the triangle, right? Now this is also very important. Centroid divides any median passing through it in the ratio 2:1. Now most of the people will know this, but they won't know which part is 2 and which part is 1. The part of the median towards the vertex, if this is the vertex, the part of the median towards the vertex will be twice as long as the part of the median towards the edge of the triangle, right? So first you need to know what median is, then you need to know what centroid is, then you need to know what centroid does to the median. Centroid divides the median in the ratio 2:1. Very important. Okay. Next, there will be many people will be confused between these two terms, altitude and perpendicular bisectors. See, altitudes are basically perpendiculars dropped from the vertex to opposite side in any triangle. Okay. Now, again, see, they are perpendiculars dropped from vertex, meaning every altitude will pass to the vertex of the triangle, right? That is a necessary condition for it to be altitude. So basically, from the vertex, you're going to drop a perpendicular to the opposite side of the triangle, right? That is what is known as altitude. Perpendicular bisector is not the same. Perpendicular bisectors, they need not pass through the vertex. They are basically perpendiculars which bisect the sides of a triangle. That's all, right? So for example, if this is a triangle, this may also be a perpendicular bisector. This perpendicular bisector need not pass to the opposite vertex. Whereas altitudes, in case of altitudes, they must pass to the opposite vertex and they must be perpendicular to the opposite side. Clear? So that is the difference between your perpendicular bisectors and altitudes. It is very important for you to know this, right? Next, orthocenter. So basically, what is orthocenter? Point of concurrence of altitudes in any triangle, right? And altitudes are what? Altitudes are perpendiculars which are dropped from vertex to the opposite side. They will always be passing through one of the vertices of the triangle. And what is perpendicular bisector? They are basically perpendiculars which bisect the edge of a triangle or a side of a triangle. They need not pass through the opposite vertex. And the point of concurrency of altitudes is known as orthocenter. The point of concurrency of perpendicular bisectors of triangle is known as circumcenter, right? Very important. And you also have to remember this. I think most of you will already know it, that when like you take circumcenter as a center of a circle and draw a circle, it will be touching all three vertices of triangle. The reason is also very important. The reason is circumcenter is a point which is equidistant from all vertices of triangle. That is the reason why if you keep the circumcenter as a center of a circle, and if you keep the radius of a circle equal to the distance between circumcenter and any vertex of triangle, you will form the circumcircle, right? See, all three vertices of triangle will lie in a circle drawn with the circumcenter as its center, right? So if this is a circumcenter, which is basically the point of intersection of perpendicular bisectors in a triangle, and if you keep the radius, that is the distance between the circumcenter and any vertex of the triangle, because circumcenter is equidistant from all vertices. You take this distance, you take this distance, you take this distance, all are going to be same, and that will be the circumradius, right? You also have to remember this. Next point you have to remember is in-center. Although this many questions do not come from in-center, but you can never predict. Advanced may ask from it at any point of time, and so may mains also, right? You can't predict the level of mains. Sometimes mains will be tough, sometimes mains will be easy, so you just have to be prepared for everything. So what is in-center? In-center is basically point of concurrency of all three angle bisectors in any triangle. Now I hope you guys understand what angle bisector is. We'll be learning about them in detail in a few minutes, but basically angle bisectors are like, it is, suppose say you have two lines, right? This is one line and this is another line, right? The locus of all the points that are equidistant from both these lines will be angle bisector. And when you draw that locus, now suppose say this is the locus, this locus will bisect this angle. This entire angle, say this will become a by 2, this will become a by 2. That is what is angle bisectors, and the point of concurrency of all these angle bisectors in any triangle will be its in-center, right? Now, this is another point you have to be very clear. It is a point equidistant from all three sides of a triangle. So, what did we learn about circumcenter? Circumcenter is a point which is equidistant from all three vertices of a triangle. Incenter is a point which is equidistant from all three sides of a triangle. And when you take any of the perpendicular distance of incenter, like in some questions they will ask you to find the in radius. Now, it's very easy to find the in radius, because this incenter is basically at equidistant from all three sides. When you take the perpendicular distance of incenter from all three sides of a triangle, they will all be equidistant, and that will be the in radius, right? So when you keep this incenter as a center of a circle and draw a circle with radius as in radius, you'll get in circle, right? So that is what I written here. I written the definition of in radius. I'll share the notes. You can go through it, right? And yeah, this is another important point that you have to remember. I think one question was asked from this. I had solved one question long back while I was preparing based on this, right? Like, you have to know the property of angle bisectors in any triangle. Now, I already told you that incenters are basically point of concurrency of angle bisectors in any triangle, right? Now, suppose say ABC is a triangle and AD is angle bisector of the angle BAC, right? So basically this entire angle is A, and now it is being bisected into A by 2 and A by 2. In that case, you will be able to say that this BD by DC will be equal to AB by AC. This is a very important property. Now, the proof of this property you would have already learnt in class 9 or class 10, but I'm not going to take up that because it's only a revision session. But you have to know this property, that whenever there's a triangle and from any vertex you're dropping an angle bisector, then suppose it's a triangle ABC and you're dropping an angle bisector AL, then this AL, right, if it divides this BC in BL and LC, you can say BL by LC will be equal to AB by AC. This is a very important property that you have to remember. Sometimes it may be asked, although the probability is low, but it was asked once, right? So you need to remember that also. And yeah, I've just written the same property here. Next one is some important notes that you have to remember, right, about all the points that I discussed so far. Centroid, what is centroid? Point of intersection of medians. Incenter is point of intersection of angular bisectors. Now, centroid and incenter always lies within the triangle. This is very, very important. See, all these points are important because sometimes in JEE what will happen is they may like give you a structure where you will end up having two triangles. Okay, now both this triangle will have centroid and both this triangle will have incenter. And when you solve for incenter of any of this triangle or centroid of any of this triangle, you may sometimes get 2 points as centroid of this triangle. Now, how will you decide which is actual centroid of the triangle? You need to know this point. You need to know the centroid and incenter, irrespective of the case, always lies within the triangle, right? But that is not the same for circumcenter, right, or orthocenter. Orthocenter or circumcenter, they may or they may not lie within the triangle, right? For example, in this case, you see, this is a circumcenter. Circumcenter is lying outside the triangle, right? This is a very important point that you must know. Note 2. For this I think is now become very obvious. Most of the people know it. For any right angle triangle, this point, that is the vertex which is opposite to the hypotenuse, that will always be the orthocenter, and the midpoint of the hypotenuse will always be the circumcenter. Now, how will questions be asked from here? You see, then it's very easy. Now, once you know the midpoint of the hypotenuse is your circumcenter, then obviously you should know circumradius will be half of the hypotenuse. So if they ask circumradius, it will be very easy question. So this is a very easy thing. I just wanted you to, most of you will already remember it, but if you are not, then you can revise it, right? Note 3. In any triangle, orthocenter, centroid and circumcenter are concurrent, and centroid divides the line joining orthocenter and circumcenter in the ratio of 2:1. This is a very, very important point. I'll again read. In any triangle, orthocenter, centroid, which is the point of intersection of medians, and circumcenter, which is the point of intersection of perpendicular bisector. Orthocenter is point of intersection of altitudes, right? They all are concurrent. What is the meaning of concurrent? They all lie in a same straight line. And the centroid divides the line joining orthocenter and circumcenter, the ratio 2:1. Many questions have been asked from this concept. You need to know this concept. You need to remember this concept. Now, many people forget like what was the order. So I usually remember like this: O, G, C, 2:1. Right? This is how I used to remember. So basically, O is for orthocenter, G is for centroid, and C is for circumcenter. And the centroid divides the line joining the orthocenter and circumcenter, the ratio 2:1. The distance between your orthocenter and centroid is 2 times the distance between centroid and circumcenter. Please remember this. This is very important. Okay, you have to remember this point. This point is very important. You may get questions from this also directly, right? Okay. Now some other important shapes and their properties. Now, why are we learning these other important shapes? Sometimes now JEE also asks like sometimes you may want to use the properties of some shape to solve a question, but in order to do that you need to know to how to identify the shape, right? You need to know like if they're given some conditions, you need to know how you can identify whether the figure formed by those conditions is actually a shape you're expecting or not, right? For that you need to know the properties of the shapes. For example, first is parallelogram. Okay, so opposite side, this is a very basic property. Opposite sides are parallel, okay, and then opposite sides are equal. AB equal to CD and BC equal to AD, and this property is also very important. This most of you might know, some of you might not also know that the when you take any two adjacent angles in a parallelogram, they sum up to be 180, meaning they're supplementary. Alpha plus beta is equal to 180 degrees, and your gamma plus delta is also equal to 180 degrees. This is also very important. This point is very very important. The like a J usually plays with diagonals, right? Like you need to remember what diagonals of different shapes do. Remember, diagonals of parallelogram bisect each other. We'll be learning how diagonals of rectangles, how diagonals of squares will be also. But as of now, remember the diagonals of parallelogram bisect each other. This is a very very important point that you have to remember. Okay. Now, to prove something is a parallelogram, you can prove any of the following things. Like if they are given, this is what I was speaking about. If they are given many conditions to the question, and you want to use the property of parallelogram, before using the property of parallelogram, you must somehow prove to yourself that the given conditions are that of a parallelogram, right? Only then you will be able to use the properties of parallelogram to solve the question. So how will you be able to say if it is a parallelogram or not? You can prove that AB is parallel to CD, and if you can prove AB equal to CD, then it will be definitely a parallelogram. Now you see, if any shape is a parallelogram, it may also be a square or a rectangle. I think you have heard, like all squares and rectangles are parallelograms, but not all parallelograms are squares or rectangles, right? So if you can prove this, you can only prove it's a parallelogram. For proving whether it's square or rectangle, you need to prove some other things also. We'll be seeing this, okay? Second thing you can do is you can prove AB equal to CD, and you can prove AD equal to BC. Then also you'll be able to prove it's a parallelogram. Third thing you can prove the diagonals of the figure which is given in the question bisect each other, and therefore you can say that I'm applying the rules of parallelogram. Then you will be able to solve the question, right? Next one is rhombus. Rhombus is basically a parallelogram with all sides equal. This everyone knows. It's a very basic property. Now see, this is very important. Parallelograms where diagonals bisect each other at 90 degree form rhombus. Diagonals also act as angle bisectors. See, both these properties are very important, right? Now, I think see, here we learned that in parallelogram, diagonals only bisect each other, right? In rhombus, we are learning that diagonals bisect each other at 90 degree. So that is the differentiating factor between your rhombus and between your parallelogram, right? And one of the differentiating factors is this, that in the case of rhombus alone, suppose say you have any rhombus, right? The diagonals will be acting as internal angle bisectors. This is a very important point that you have to remember. Both these points can come helpful sometimes in questions if they give rhombus, right? Okay. Next is rectangle and square. These two are very basic things. That's why I didn't write much about them because most of you might already be knowing about them, right? In rectangles, all angles are equal 90 degree. The diagonals part is again important. Please remember, you need to remember the diagonal. You need to remember the diagonal property in everything. In parallelogram, diagonals bisect each other. In rhombus, diagonals bisect each other and they are perpendicular to each other. In rectangle, diagonals are of equal length. They are not bisect each other at all. They are only of equal length, right? In square, you see diagonals bisect at 90 degree and are equal. So in square, diagonals do almost everything. Diagonals bisect each other. Diagonals are perpendicular to each other, and diagonals are also equal to each other, right? In rhombus, diagonals bisect each other and diagonals are perpendicular to each other, but diagonals are not equal to each other, right? You need to know how diagonals behave in different shapes. I hope you know. If you don't, please revise, okay? And square, all sides are equal, all angles are 90 degree, right? So I hope you got a little bit gist, right? I hope you're right now remembering certain properties that you learned in class 11, right? So I just revise it one more time. In parallelogram, your diagonals bisect each other. In rhombus, diagonals bisect each other and they're perpendicular to each other. In rectangle, your diagonals are only equal to each other, you do not bisect at all. In square, your diagonals bisect each other, they are perpendicular to each other and they are also equal to each other. This is very important for you to remember, so please remember. Clear? Okay. I hope now it's okay, right? Next one, certain formulas that you have to remember. First one is centroid. This is very easy formula. Suppose you have x1, y1, x2, y2, and x3, y3 are three vertices of triangle, and centroid will be x1 plus x2 plus x3 whole divided by 3, y1 plus y2 plus y3 whole divided by 3. Very easy, right? And orthocenter. Now I'll tell you something. Okay, this formula which I am about to give to you, this will mostly be of no use, because they mostly won't allow you to use this formula, because if you use this formula it will take a lot of time, right? To find such things now, you need to use a definition that we learned before. You see, I told you that orthocenter is a point of intersection of all altitudes in a triangle, right? And what are altitudes? I told you altitudes are basically lines drawn from vertex of triangle to the opposite side in such a way that they are perpendicular to the opposite side, correct? Basically perpendiculars of sides which pass through vertex opposite to it, that is altitudes, right? But I told you altitudes must pass through the vertices. I told you that, right? Now the point of concurrency of all these altitudes will be the orthocenter. Now it is using this property that you'll be able to find. They may give anything in J. They may either give you directly vertices. If they directly give you vertices, nothing. You can you know, like we'll be learning how to write straight line equations after this. But once you learn that, you'll be able to write the line equations of either of the two altitudes. And once you get the line equation of either of the two altitudes, find the point of intersection. That will be your orthocenter. Do not use this formula unless it is needed to. But this formula is there in a syllabus. So sometimes if they give your A, B, and C, you must know how to use this formula. That is why I am giving this formula. Apart from that, if they give the side length, or if they are giving your vertices, or if they are giving the equation of one altitude and asking you to find the orthocenter in any such case, don't use this formula. Clear? Okay, so that's what I've written here. See, however, we won't be using this formula for finding orthocenter. We will find altitudes and then find their point of intersection. That's how we'll be doing it for finding orthocenter, right? But anyways, you have to remember this formula because this is still there in a syllabus. So remember it, so that if any question comes and if that is directly a formula based question, you should not leave it, right? Because many people will be able to score in that question, and if you leave it, the percentile will go down. So you should not leave it. Memorize this formula, please. Okay. Similarly, there's a formula for circumcenter also. It's almost the same thing. Here you use tan, here you use sine of 2a. That's all. There is no other difference. But I hope now you know, like you won't be using this formula also. You won't be using this formula most of the time. So what is circumcenter? Circumcenter is point of intersection of perpendicular bisectors, right? You will be writing the equation of any two perpendicular bisectors of the sides of triangle, and then you will be able to find the point of intersection to find circumcenter. You won't be using this formula most of the time, but you have to remember it. Okay. Okay. This formula is important. Incentrous formula is important. Incentrous formula is not the same as your circumcenter or as your orthocenter. This is important. This has come many times in G, and this will continue to come. Okay, so that is, what is the formula? The formula is, suppose say you have a triangle having what is x1 y1, x2 y2, and x3 y3. Then your incentrous x coordinate will be given as a times x1 plus b times x2 plus c times x3 equal to a plus b plus c. Or what is ABC? ABC are the length of the sides opposite to the vertex. For example, if x1, you are taking x1, okay, so you go to the side which is opposite to this vertex, it is BC. BC side length will be A. So you do A times x1. Similarly, suppose you are taking x2, you go to the side opposite to B, the vertex B, which is AC, its side length will be B, so B times x2. And similarly, if you have x3, y3, go to the side opposite to that, you have C times x3 over whole A plus B plus C, that will give you x coordinate, y coordinate of ncert. Clear? Now, here is a way in which I used to remember all these formulas for incenter, orthocenter, circumcenter, and for your centroid and all. Basically, you can remember it as any point. They give centroid, they give orthocenter, they give incenter, they give circumcenter. If you want the formula, I can remember like this: lambda times x1, lambda 1 times x1, lambda 2 times x2, lambda 3 times x3. Like lambda 1 into x1 plus lambda 2 into x2 plus lambda 3 into x3 whole divided by lambda 1 plus lambda 2 plus lambda 3, and lambda 1 into y1 plus lambda 2 into y2 plus lambda 3 into y3 whole divided by lambda 1 plus lambda 2 plus lambda 3. And this lambda 1, lambda 2, lambda 3 will take different values depending upon the point which is given. Like suppose if it is a centroid, then your lambda 1 will be equal to lambda 2 will be equal to lambda 3, that will be equal to 1. Suppose it is an orthocenter, then lambda 1 will be equal to lambda 2 to lambda 3 equal to tan times A. Now what is tan A? This one. I told you now, x1 times tan A. Now what is this angle? I also tell you that. See, I have written that. Where A is an angle included between the two sides whose point of intersection is x1, y1. That is, if you are taking x1, y1, and this is your angle, this is the angle A in that case. Okay, so in case of orthocenter, there will be tan of A. In case of circumcenter, all this lambda will be equal. They will be equal to sine of 2A. And in case of centroid, it will be equal to 1. And in case of incenter alone, they will be different. It will be lambda 1 equal to A, lambda 2 equal to B, and lambda 3 equal to C. You can remember it this way if you want to remember the form. Okay. Next, area of any coordinate plane. Now, I think this is also now become very common. Like, see, like if you have coordinate of any n sides, now The only thing where people can do mistake in here is, suppose say you have a quadrilateral like this, some quadrilateral you're having, okay, and this is some point, this is 1 point, this is 1 point, this is 1 point, this is 1 point. Always while you're using this formula, where, right, like if there is a quadrilateral of n sides having vertices on it, like as x1 y1 x2 y2 all the way till x and yn, its area can be given as, like, you, only thing where people make mistake is they don't write the points in order. Here either you must go in clockwise or you must go in anti-clockwise direction. So you must first write this, then this, then this, then this, then this, or first this, then this, then this, then this, then this, right? You can't write this and then this and then this. So that is the only thing where JE can confuse you. So you must always write it in a cyclic order, either in anti-clockwise direction or clockwise direction. That will not be a matter, but you need to be writing it in cyclic order, or else the answer will go wrong, right? So once you write it in the cyclic order in this way, then you can solve it. Like how will you solve it? See, so basically you will first be multiplying these two, x1 to y2, then you will be multiplying these two, x2 to y3, and while you go in this manner, now when you go down, you will be putting positive sign and everything. Then when you come to the last one, that is x1 into y1, then you will be going up again, right? Then it will be x1 yn, x and yn minus 1 and so on, and when you go up, you will be putting everything in negative sign, and you should finally take the mod, because area can never be negative. And then you'll get the half, you take the half of that will give you area of the quadrilateral, right? Now similar thing can be done for triangle also, obviously, because triangle at the end of the day is a quadrilateral, yeah, but it's a three-sided quadrilateral, that's all, right? Now so the same thing can also be done for triangle as well, and in that case if area comes out to be 0, then that means all 3 points are collinear. Now this is the condition that we use for 3 points collinearity. Like if you are given any 3 points x1 y1 x2 y2 x3 y3, just write them in the above manner. See, yeah, I also forgot to tell you one other point. See, once you go until x and yn, you should again write x1 y1, only then this formula work. Whatever point you started from, now same point should be there again last, you should add that, okay? So suppose say you want to do for triangle, okay, you have x1 y1 x2 y2 and x3 y3, right? Then while using this formula, it will be x1 y1 x2 y2 x3 y3, and again you have to write x1 y1 here, okay, and then you have to solve as I told you, and then you have to take half, that will give you area of the triangle. Now suppose this value if it comes out to be 0, that means all these 3 points are collinear, because if 3 points are collinear, then they'll never be able to form a triangle. In that case, area of the triangle formed by them will also come out to be 0. Right, so that's a point, that's a condition which can be used for testing whether 3 points are collinear or not. Okay, next we'll go to straight line equation. Now from here I think everyone will know a lot, like slope m is equal to tan theta, and theta is the angle made by the line with the positive direction of x-axis, very easy. And then some important basic points you have to know. If line is horizontal, slope is 0. If line is parallel to x-axis, if this is x-axis, this is a line, slope is 0. If line is perpendicular to x-axis, it's parallel to y-axis, then slope is not defined. Again, very easy. Formula for finding slope of line joining 2 points x1 y1 x2 y2 will be y2 minus y1 by x2 minus x1. Again, very easy formula. Intersection of any line. This is very important. Most of the people get this wrong. See, what is x-intercept of any line, right? X-intercept of any line is basically the x-coordinate of the point where the line intersects the x-axis. That's it. Suppose this is your x-axis. This is your x-axis. This is your line. This point will have some x-coordinate, that will be its x-intercept. For example, this is another line. So this point will have some x-coordinate, that will be the x-intercept. X-intercept can also be negative or it can be positive, right? This is very important. Remember, intercepts have sign. They are not always positive. Like for in this case, if you see, you have 2, 0. Say x-intercept is 2. In this case, x-intercept is not 2. X-intercept is minus 2. Many people just tend to think that intercept is only the distance. No, intercept is not distance. Right, intercept is only the x-coordinate of the point. If it is x-intercept, it is only the x-coordinate of the point where the line meets x-axis. Right, x-intercept is also not defined in this case. See, in this case, don't write x-intercept as 0. Okay, whenever a line is parallel to the x-axis, x-intercept is not 0. X-intercept is not defined. This is a very important point that you have to remember. Sometimes it may be asked in assessment recent type questions. In JEE it may be asked, like in one statement they may give that if a line is parallel to x-axis, its x-intercept is 0. No, its x-intercept not defined, right? This is a very important point for you to remember. Simply y-intercept you can now think for yourself. See, y-intercept is nothing. Y-intercept is when a line intersects the y-axis, the y-coordinate will be y-intercept. That can also be positive or negative, or can also be undefined. When it's undefined, if you have a line parallel to y-axis, y-intercept is undefined, right? Very easy. some important points. You see, if a line makes equal intercepts, then its slope will be definitely -1. Because if a line makes equal intercepts, the intercepts must also be of the same sign. You see, now you will be thinking, why can't it be 1? See, for example, slope is 1. Let's assume slope is 1. Okay, let's assume this is 45 degree and slope is 1. Now what is this? This is 1, 0. What is this point? -1, 0. Do they have equal intercepts? Do they have equal x intercept and y intercept? No. The length of the x and y intercept is equal, but the x and y intercepts are not equal, because x intercept in this case is 1, whereas y intercept in this case is -1. They are not equal, so slope can't be equal to 1. So if a line is making equal x and y intercept, that means the slope of the line will definitely be -1. It can never be +1. Okay. If a line makes intercepts of equal length, then its slope can be +or -1. This is very important to remember. Okay. Different forms of straight line. As of now, if you're in class 12, if you've completed this chapter, this must be in your tips. The different form of straight line must be in your tips, but you can revise it from this video, right? First one is slope intercept form, very easy here. Y equal to mx plus c, you know slope, and c is what? C is a y intercept, right? And second one is 2-point form. Now what is 2-point form? A 2-point form, this is a very important thing, right? So basically, before this we used to learn something called 1-point form, which is basically if you're given a point through which a line passes and you're given the line slope, then you will be able to write the line's equation. Similarly, this is 2-point form. Okay, so first we'll learn 2-point form. Okay, so the equation of line passing through 2 points x1, y1, x2, y2 is given by. So if you are given that a line passes through 2 points x1, y1, x2, y2, then this equation can be given by y minus y1 equal to y2 minus y1 by x2 minus x1, which is the slope of the line, into x minus x1. Okay. Next is slope point form. That is a 1-point form which I was talking about. Basically, when slope m of line is known and it passes through 1 point x1, y1, then in that case the line's equation can be given as y minus y1 equal to m times x minus x1. Clear? Intercept form, again I'm telling you, equation of line with x intercept as a and y intercept as b is given by. See, if in your question they have given that the line makes intercept of 2 in y axis. Okay, so what will take us b here? Actually, b can't be taken with this information, because if they give intercept of 2, it can be 2 as well as it can be -2, because they only given the length of the intercept. If they say that the line intersects the y-axis at 0, 2, then you can say that y-intercept is 2. So again, I'm telling you, here also in A and B, you need to take the sign. It should be taken in sign. Only then intercept form will work. I remember in one of the tests which was given to me in Fiji, I made a mistake because I did not take the intercept with sign. I have to use this intercept form x by a plus y by b equal to 1. And instead of taking this b as -2, I took b as 2. Which is the reason why I made a mistake there. So this is very important point for you to remember. The intercept form is known by everyone. X by a plus y by b equal to 1, where a is x intercept, b is the y intercept. But that must be taken along with the sign. Okay, this is very important. Normal form, this is less used nowadays, but because in old questions now, I think the JEE 2001, 2002 and all, they were asking this. But right now, I don't think they are asking. In the PYQ book, when I solved it, I did not find many problems, but you need to still know. So basically the normal form is something like this: x cos alpha plus y sin alpha equal to p, where what is alpha? See, basically alpha, like if this is a line, which is given to you, then if you drop a perpendicular through the origin to the line, perpendicular from the origin to the line, it will make an angle alpha with the positive x-axis, that is your alpha. And the length of this perpendicular, basically the perpendicular distance of the origin from the line, that will be your p, right? So once you, if you are given any line, you will be able to drop a perpendicular on that line from the origin. Yes, obviously. The length of this perpendicular will be p, and the angle this perpendicular makes with the positive axis will be alpha. Then it will be very easy. Then you will be able to write the equation of the line as x cos alpha plus y sin alpha equal to p. Okay. Now this is very important. This p should be positive, obviously, because distance can never be negative, and alpha must belong to 0 included 2 pi not into. Clear? Clear. Now general form of line. So all above forms now, eventually when you when you write the line equation by using any of the above forms, you will be ending up with the line equation of this form: ax plus by plus c is equal to 0. But in some questions, they will already give you the equation of line. From there, if you want to calculate the information that is known to you within a very less amount of time, now you need to know these 3 formulas is very, very important for you. Right? You memorize them, and once you start solving questions using them, you'll be able to see that the time that you take to solve questions will be lessened in terms of this chapter, right? So slope will be minus a by b. which is basically minus coefficient of x by coefficient of y. So whenever you're given any equation of form ax plus by plus c, the slope of this line will simply be minus a by b, minus coefficient of x by coefficient of y. Similarly, the x-intercept and y-intercept can also be very easily calculated. It will be minus e by n minus e by b. So as soon as you see any line is given to the question, you need to be able to calculate these three things on your mind, because most of the questions in JEE mains and in JEE advanced do not directly come from this one chapter. It will be somehow related with this chapter and circles, or with this chapter and hyperbola and something like that, right? In that case, whenever you want to very quickly find out what will be the eccentricity line, you will not be able to you should not put y is equal to 0 and then solve for x and all. You should directly be able to say it will be minus c by b. It will be minus c by b, right? So once you are given any line, you need to be able to see these three things. You need to be able that, okay, this much data is given to me, slope is given to me, the x-intercept is given to me, and y-intercept is given to me. Then you must think what you can do with that, right? So slope will be minus a by b, minus coefficient x by coefficient of y. Intercept, x-intercept will be minus c by a, and y-intercept will be minus c by b, right? Very important. Trigonometric or polar form. This is also very, very important. So this form, instead of learning it as a form of line, you need to know what is its actual purpose. See, this is specifically used when a point h comma k is known to exist on a line, and another point is to be taken at a distance r from h comma k along the same line. That is, if you know that h comma k lies on any line, okay, and you want to take some other point p at a distance r from h comma k along the same line, then how will you write the equation of point p? You can write how will you write the coordinates of point p? Coordinates of point p can be written as h plus r cos theta and k plus r sin theta. Simple. Where this theta is basically slope of the line. You'll be able to, like, suppose they give your slope of line is, suppose, say root 3. Then what will be theta? Very easy, na? Tan theta must be equal to root 3. So theta will be equal to 60 degrees, right? So in that case, you'll be able to take theta, and once you take theta, you'll be able to find the coordinates of point P also. And this is also very simple. See, you can take two components of r. You would have used this a lot of times in physics. This is r, so this will be r cos theta, this will be r sin theta. So x coordinate is moving by r cos theta, and y coordinate is moving by r sin theta. That's all. That's the simple explanation, right? Now, some other important basic points, right, which you will already know. Suppose, say, the slope of line L1 is M1 and that of line L2 is M2. Then if L1 is parallel to L2, then M1 must be equal to M2. If L1 is perpendicular to L2, then M1 into M2 must be equal to minus 1. This is very easy. Angle between two lines. This is also very important concept that you have to, and I think this formula is right now, you should have memorized this formula by now. If you have not, if you have forgot, then please revise now. So tan will be equal to mod of M2 minus M1 by 1 plus M1 M2, right? Now, why are we using mod here? See, you know that tan, you have learned in trigonometry that between 0 to pi by 2, tan will be positive, and between pi by 2 to pi, tan will be negative. So why are we using mod? Because you want tan to be positive. Why do you want tan to be positive? Because generally when they ask angle between two lines, in JEE syllabus, whenever they ask angle between two lines, we need to consider acute angle value. We should not consider the obtuse angle. And if you want to take acute angle, this value must be positive. That is why we are applying mod here. Okay. But if you want to take the obtuse angle, then you can simply take by just subtracting this angle from 180. Like suppose say you are getting 50 degrees here. Okay. If you subtract 180 minus 50, what will be 130? So 130 will be the obtuse angle between the two lines. So it's not a very big deal to take the obtuse angle between two lines, but generally we need to take acute angle between two lines if nothing is mentioned in the question. That is why we are applying mod. Okay. Clear. This is also now become very simple. Now, this is very important. This formula I wanted to remember, right? Like, because it is used in a lot of questions, and I used to remember because I solved like I think 6 or 7 questions based on this one concept itself. So I just directly made a formula for it. See, slope of line L that makes angle theta with the line L1 having slope ms. That is, suppose in the question they are already giving you some line L1. Okay, some line L1 is given, and you want to form a line L which is making an angle theta with this line L1. And some other information will be given, that line L passes at one point, or line L is perpendicular to some other line or something. They will be given. No, line L passes through one point, something like that will be given, right? If something like that is given, then this line L can have two slopes. Now, why can it have two slopes? Because this theta can be clockwise, or this theta can also be anti-clockwise, right? So this line will have one slope, and this line will have one slope, and that is given by this M1 or M2. Is M plus or minus tan theta, 1 minus plus M tan theta. See, this is very important formula. I'll explain it. Okay. That is, suppose you have any line L1 and you want to find slope of line L which makes angle theta with line L1. Then it will be M plus or minus tan theta by 1 minus plus M tan theta. That is, if you use positive above, it should be negative below. If you use negative above, it should be positive below. Clear? And why are these two slopes coming? Because theta can be taken in the clockwise manner, theta can also be taken in the anti-clockwise manner. So please revise this formula and keep this formula in mind. Okay, it may be helpful because if you go procedural wise, if you go procedural wise, and if you find the slope of that line, it will take some time. And J means you only have 2 minutes to crack questions, so you need to know such formulas. If you have forgot, please revise it now. Okay. Okay. Now the next point is, if any point is given by x1 comma y1 and line L equal to ax plus by plus c is given, then L of x1 comma y1 is a value obtained by substituting x1 comma y1 in the line L. Okay. Now basically this is just a denotation. I'm just telling you what the denotation of L of x1 comma y1 means. That is, if you have line L equal to ax plus by plus c is equal to 0, that is the equation of line. Then if I tell you what, like if I use L of x1 comma y1, what that means is I am just speaking about the value obtained when x1 comma y1 has been substituted in the equation ax plus by plus c. Clear? So if L of x1 comma y1 equal to 0, that means the point lies in the line. Okay. Now suppose you have 2 points. This is another important thing for J. Suppose you have 2 points, x1 comma y1 and x2 comma y2, right? Then if L of x1 comma y1, which is a value obtained by putting x1 comma y1 in the equation ax plus by plus c, into L of x2 comma y2, which is a value obtained by putting x2 comma y2 in the equation ax plus by plus c, if that is greater than 0, the product is greater than 0, that means points lie in the same set of the line. What do I mean by that? If this line divides this 2D space into 2 parts. Now this is part 1, this is part 2. Now a point, if point 1 is also here, point 2 is also here, that means they are on the same side of the line. But if point 1 is here, and point 2 is here, that means they are on the opposite side of the line. So if you substitute this point in the line and you substitute this point in the line equation, and the product becomes positive, that means these points are on the same side. But if the product is negative, that means the points are on the opposite side of the line. Simple, right? This concept may also be used sometimes in J main, so you have to know this. Points lying on the same side, points lying on the opposite side of the line. Clear. Next, length of perpendicular or perpendicular distance to point from any line L. This is also very easy here. See, suppose you are given any line L equal to ax plus by plus c, and if you are given some point h comma k, you want to find the perpendicular distance of this point h comma k from the line, then you will be using this formula. It will be mod of, just substitute this point here, it will be a times h plus b times k plus c whole divided by root of coefficient of x and y. So root of sum of squares of coefficient x and y, root of a square plus b square, right? I hope this is many of you might already be using this formula, but remember this distance, perpendicular distance of any point from line will be just substitute that point on the line whole divided by root of a square plus b square, and it's mod because distance can never be negative, right? Now some important notes. So length of the perpendicular from the origin to any line will rapidly be mod of c by root of a square plus b square. You can remember this. And note 2, distance between two parallel lines will be c. Why are they parallel? Because you see, what did I tell you about the slope? I told slope of any line is minus coefficient of x by coefficient of y. Here coefficient of x and coefficient of y in both cases is same. So slope is same. If slope is same, they are parallel. That also I already told you. In that case, the distance between two parallel lines will be mod of c2 minus c1 by root of a square plus b square. Very important again. Okay. Now, how will you determine whether 3 straight lines are concurrent or not? This is a very important concept because I think one direct question has come from this. I think they are given 2 lines, and in the option they are given a third line, and you only had to choose like which of the following options have a line which will be concurrent with about 2 lines. How will you find that? You will be finding that using determinants. Now if you don't know how to expand determinants yet, I think you already learned in vectors in physics. But if you don't know, then as of now you can skip, and once you learn determinant, you can use this formula to do this, right? So basically, if 3 lines are concurrent, suppose the line L1 is a1x plus b1y plus c1, and L2 is a2x plus b2y plus c2, and L3 is a3x plus b3y plus c3. If these 3 lines are concurrent, then the coefficients a1, b1, c1, a2, b2, c2, a3, b3, c3, determinant of all these 9 values will be equal to 0. If these 3 lines are concurrent, determinant of all these 9 values will be equal to 0. Very, very important point. Okay. Family of lines, right? Now this is also this concept is very important, and family having same slope is not that much important because that's just a very basic point. If they are given that a line has a slope m equal to 3, then there will be there can be infinitely many lines with a slope m equal to 3, yeah. So if you want to determine the family in such case, then you will be using y equal to kx plus c. So in this case, it will be y is equal to 3x plus c. So if I write this, every line that the questioner has asked is, so if in the question you are reading a statement, a line having slope 3, okay, then immediately you must know that okay, it belongs to a family and I can represent this line as y equal to kx plus c. Right, that is case 1. That is when you know the slope of a line, then the family can be given as y is equal to kx plus c. Case 2, this is very important case. Right, family of lines passing through point of intersection of two other lines L1 and L2 is given by. That is, suppose say you have two lines L1, L2. There is one point of intersection, right? And I think you already know that through a point infinitely many lines can pass, right? Right. So the family of lines which are passing through the point of intersection of these two lines can be given as L1 plus lambda L2. This has been used many times in J. Okay, they'll give any two lines and they'll say that a third line is passing to the point of intersection. Then immediately you must understand that the third line will be of the form L1 plus lambda L2. Right? The line L, the third line L, the third line L can be given as a form L1 plus lambda L2, and this lambda could be found in some way or other. Now suppose say they are saying that you have two lines 3x plus 5y minus x equal to 0 and 4x plus 8y minus 10 equal to 0. Suppose say they gave these two lines other, okay, and suppose they are asking you to find a line which passes through the point of intersection of these two lines and has a slope of 5. Right, so one way to do it is you can solve these two lines, you can find point of intersection, then you have the point of intersection and the slope, you can put one point form. Or the other way to do is just put L1 plus lambda times L2 equal to 0 and then find lambda. How can you find lambda? Because suppose say, I'll do it. Suppose say you have 3x plus 5y minus 6 plus lambda times 4x plus 8y minus 10 equal to 0. From here, you write it in the form of ax plus by plus c equal to 0. And then from here, I already told you what will be the slope of this, minus a by b, right? Take slope of this line as minus a by b and equate it to whatever slope is given in the question. From there, you'll get lambda. Then you put lambda here, you'll get the equation line, right? So this can also be done, okay? So to find, what I'm trying to say is to find lambda, some condition will be given in the question. Use the condition, find lambda, then find your line, okay? Next one, angular bisectors. This is very, very important. This is like, I would say this is like the most important topic in this entire chapter, because this from here only a lot of questions have come. Okay, so angular bisector, I already told you, I think angular bisector is a locus of all the points that are equidistant from two given lines, right? So how will you take the equation of this locus, or how will you take the equation of angular bisector? This is also very much known. So basically mod of ax, suppose you have two lines, equation of angle bisectors of two lines, let L1 is equal to this one, let L2 equal to this one. Then angle bisector of these two lines is given by mod of a1x plus b1y plus c1. That is, just take the equation line, put it here, by root of a1 square plus b1 square equal to mod of a2x plus b2y plus c2 by root of a2 square plus b2 square. Okay, when you open this model, you get something like this. L1, what is L1? This equation, and what is L2? This equation is L1, and what is L2? This equation is L2. Okay, so when you open the model, you get something like L1 by root of a1 square plus b1 square will be equal to plus or minus L2 by root of a2 square plus b2 square, right? And when you take it, this will be L1 plus or minus under root of, see, cross multiply, it will be under root of a1 square plus b1 square by root of a2 square plus b2 square. So L1 plus or minus under root of a1 square plus b1 square by a2 square plus b2 square, and L2 will be equal to 0, right? This will be the equation of angle bisector. Now, how to determine which sign you have to take? Like should you take plus sign or should you take minus sign? Now basically, why are there two? Obviously there will be two, because see, suppose say you have line L1, line L2. Okay, what is this angle? This is one angle between the two lines. This is also an angle between two lines, na? So this can also be an angle bisector. This can also be an angle bisector. So one will be acute angle bisector, another will be obtuse angle bisector. That is why there is two, right? Now, if they have asked in question specifically the acute angle bisector or obtuse angle bisector, how will you know which sign? Okay, for that, first you have these two line equations, right? You make these two constants of the same sign. Once you make these two constants of the same sign, then calculate the value of a1 a2 plus b1 b2. Right, see, after making the sign of constant in both equations same, calculate a1 a2 plus b1 b2. And suppose say your a1 a2 plus b1 b2 is 5. Now 5 is positive. Then in that case, you take the positive sign for the obtuse angle bisector. That is, I'll explain one more time. If you have two lines L1 and L2, okay, and you want to find the obtuse angle bisector, so which sign will you be able to, which sign will you be taking, right? That is the question right now. For that, first make the sign of C1 and C2 same, then calculate the value of A1 A2 plus B1 B2. Okay, now whatever is the sign of the value of A1 A2 plus B1 B2, you take the same sign in this equation, and that will give you the equation of the obtuse angle bisector. If you want acute, then take the opposite sign. Clear? First, what you'll do, you'll make the sign of the constant same. Don't forget to make the sign of constant same. That is what most of the people make mistake in that only. I also made mistake in that only. I think I made a mistake in that in my JEE mains. That was the only question I think I lost in my JEE mains in maths, and which is the reason my percentile went down in math. So like you need to make the constants of same sign. Once you make the constants of same sign, then you calculate the value of A1 A2 plus B1 B2, and if that is positive, then take positive sign for obtuse angle bisector, and if that is negative, then take negative sign for obtuse angle bisector, and for acute angle bisector, take the opposite sign. Like if A1 A2 plus B1 B2 is coming out to be positive, then take negative sign for acute angle bisector. If A1 A2 plus B1 B2 is coming out to be negative, then take positive sign for acute angle bisector. Clear? I hope it's clear. It's a very important point. These are mistakes I made, so I just don't want you guys to make the same mistake. So always keep in mind that you have to make the constants in the same sign first. Either make both the constants in positive sign or make both the constants negative sign. That doesn't matter, but make them both in same sign first. Clear? Next one is how to find the equation of angle bisector containing any point P. Now you see, suppose say this is line L1, this is line L2. Okay, so this is one angle bisector, this is another angle bisector. Now you see this point P lies in the region which is created by angle bisector B1. Right? So when they ask in question, find the equation of the angle bisector containing the point P, you must find the equation of angle bisector B1. That is what I have written here. In the above example, point P lies in the region created by B1. Therefore, we must get the equation of B1 for that. We must get the equation of B1. For that, simply calculate L1 of P into L2 of P. Whatever the sign is, same sign must be used in the formula of angle bisector to get the equation of B1. That is, you have L1, you have L2. I already told you L1 of any point. Whenever I use this representation, means I'm substituting that point in the equation of L1 and I'm finding the value. Substitute point P in the equation of L1, substitute point P in the equation of L2. Then take the product of both of these. Whatever is the sign. Like suppose say the product comes out to be 10. Okay, now 10 is positive, so then whatever is the sign, you use the same sign in the above equation. In this formula, we had this formula for angle bisectors. You use the same sign here, you will get the equation of the required angle bisector. In this case, you will get the equation of B1. If suppose say I am substituting point P in L1, I am substituting point P in L2, and product of L1 of P and L2 of P is positive. If I use positive in the above formula, I will get the equation of B1, which is basically the required equation, because B1 is the angle bisector containing the point P, right? So with this, I hope most of the concepts are over. The only concept which I have not covered for this specific video is pair of straight lines, because pair of straight lines by itself is a very important topic. I will be covering it in the next video. Now next I will be uploading some important questions which I revised before my JEE mains for straight lines. Right, I'll be uploading that in my channel very soon. You guys can try it out, and if you guys are comfortable with that questions, and if you have revised all the concepts, that means fine. Now it's not that now you revise, so you'll just leave this chapter till your JEE mains. No, after a month or so, please again revise by yourself. Right, keep on revising, because that is what will help you at the end. Right now, whatever you're learning, it's well and good. You need to do that. You need to improve knowledge, but you also need to revise what you've already learned. Right. So I hope this video is helpful. Thank you.